So this is about understanding how consumers make choices, utility as a measure of satisfaction or benefit, and how rational consumer behavior and how we put our preferences into action in our ordering priorities. There are also constraints on consumer choices and the equilibrium in consumer decision making. So what you'll find is overall that utility is how we measure our satisfaction we derive from consuming various goods and services. Rational consumer behavior is, of course, to maximize your satisfaction. Your constraints are naturally your budget because we have endless ones but limited resources. And this leads to consumers having to make some tough decisions. So when we look at utility, there is an interesting concept called marginal utility. So utility, as we've just mentioned, is the satisfaction or benefit a consumer derives from consuming a good or service. Marginal utility is the additional satisfaction gained from consuming one more unit of that good or service. So you can see that depicted in the graph on the right. While total utility may continue to increase, marginal utility tends to have a decreasing value with the number of units consumed. You'll notice that when you are eating a few McDonald's hamburgers, for example, the first burger you derive the most satisfaction from. It's amazing and delicious. The second burger is good, so overall you're feeling better about having eaten it, but you didn't quite, weren't quite as hungry for it. So in that case, you did suffer less utility than you did from the first. And so we continue until you get to a point of disutility. Okay, so total utility increases as consumption increases, but it tends to do it at a diminishing rate. Rational consumers aim to maximize total utility within their budget constraints. So marginal utility typically decreases with additional consumption. Okay, so that's why total utility and marginal utility on the bottom are measured differently. So when marginal utility equals 0, total utility is maximized. What that simply means is that when you are deriving no additional satisfaction from eating an additional unit of this product, that means that your total utility is now maximized. From here, we will have only negative consequences. So with negative marginal utility occurs when there is additional consumption. So despite the fact that you've hit 0 marginal utility, so in this case, eating an additional burger will only make you feel sick. So at that point, you are starting to diminish your total utility. Overall, as a person, you are now feeling worse off than you did before you were received no utility from the previous burger. So this brings us to another interesting concept. So because marginal utility tends to diminish as we consume more, we have applied this to a law. You'll see this law many times in economics, specifically with relating to marginal. So marginal, that specific word means one additional unit. So you'll see it applied to marginal cost, marginal profits, marginal product, in this case, marginal utility. Utility, as we mentioned before, is all about measuring satisfaction. So as a consumer increases consumption of a good or service, the marginal utility derived from each additional unit typically declines. That is the word for word law of diminishing marginal utility. So the first units of consumption provide the highest level of satisfaction, obviously. So what we've done here on the graph on the right is we've actually provided you with values. So this is just as a simple example of you eating apples. Okay, so from the first apple you consume at point A, you'll notice that it still has this diminishing curve in the same way that your demand curve does. Okay, we'll integrate that at a later stage. That's why this is demand theory. We are considering why consumers make the decisions they make. So, how many of something we demand is very much determined by how much satisfaction we expect to derive from buying or receiving or consuming that additional product. So first unit of consumption is where we receive the highest. That apple gives you 25 utils of satisfaction. Okay. The additional unit provides progressively less satisfaction. So by the time you eat the second apple, now you're only receiving about 17 utils. By the time you consume the third apple, you're sitting at around 12 utils. By the time you get to point E, when you've consumed 5 apples, at this point you have maximized your total utility. You are now, by eating the sixth apple, leading to negative consequences. So eventually, your marginal utility may become 0 or even negative. I'm sure you've all experienced that when we've just had too much of a good thing. Okay, so this explains why all demand curves slope downward. We derive less satisfaction the more we consume. With demand curves, we demand less of a product the more expensive it is, and the cheaper it is, the more of it we demand. So another example, just so that we're completely clear before we move on. The first glass of water when you're thirsty, high utility. Second glass, moderate. By the time you get to the fourth glass, you are just saturated with water. And you actually, consuming too much can actually make you feel a little bit sick. So we look at different types of marginal utility. So here we have average magnitude versus marginal magnitudes. Okay, so this becomes quite important when we start looking at marginal costs and average costs, for example. But just so that you understand how these graphs tend to move. So when you're looking at average magnitudes, you look at the total divided by quantity. With marginal, again, you're looking at one additional unit. Okay, so typically average reflects a cumulative effect. So we're looking at how does this impact overall, whereas with marginal, we're looking at the incremental effect. So what does adding one additional unit do to the overall value? Okay, so a typical example of this will be marginal costs, which we will cover later in the semester, but it is useful to just tie your mind here to where marginal and average will be used later on, because these are recurring themes in economics. So when the marginal is greater than the average is being pulled up. And when your marginal is less than your average is being pulled down. This is very much the same with your utility. So when the marginal utility goes negative or 0, you will start to experience an average drop, okay, in overall quality. So at this point, it is very useful for us to consider the types of utility. Now, this is very likely to be an exam type question, so I'm going to spend a little bit of time here. So we have two types of utility. We have cardinal utility and ordinal utility. Okay, so very often this could be a 4 or 5 mark question, perhaps even going a little bit further, where you're asked to explain the differences between these two. So cardinal utility can be measured in absolute utils. You can understand exactly how much you are deriving. So 1 unit of this will give me 10 utils. 2 units of this will give me 20 utils, etc., etc. With ordinal utility, utility can only be ranked or ordered. So for example, um, when it comes to algorithms are brilliant at doing this. So they rank things. They cannot give you an overall satisfaction. Oh, a perfect example. Your streaming services use an algorithm to order the things that you want to see. Okay, so if you're looking at Netflix, they will give you your suggested movies and series based on your preferences that they have been tracking. The same thing will happen on your social media account. They put things that are most likely to hit your preferences and ideas. On the other hand, a website like Rotten Tomatoes is allocating a specific level of satisfaction you should derive from watching that specific movie or video. Okay, so there are meaningful differences in utility when you are looking at cardinal utility because there is an absolute fixed amount of satisfaction you expect. Now, obviously, this will vary in opinion, but overall, the idea is that with a cardinal utility, you can ascribe a specific value. So bundle A gives you 30 utils. Bundle B will give you 20 utils. Okay. However, with ordinal utility, it's very much only the order of the preference that matters, not the amount of satisfaction you derive from it. So you prefer bundle A to bundle B, but you prefer bundle C above both of those. Okay, so the one was developed by classical economists, that would obviously be cardinal utility, and the other was developed by modern economists. So obviously in today's world, it's less about being able to attach utils. It's more about ranking the order in which we have our needs and wants. So that's why modern consumer theory is predominantly concerned with ordinal utility, though it is still very important to understand that there are some roots in cardinal utility because that's how we measure things in comparisons. So the ordinal approach obviously requires fewer assumptions about consumer behavior, and your indifference curve analysis is based on ordinal utility, simple preferences or rankings. Cardinal utility is still useful, but for specific applications. Okay, so now we start moving into some interesting graphs. So you will be asked in your assignment and potentially in your exam to combine these two graphs, both between either the utility graphs, the indifference curves, the budget lines, and we're going to cover all of them now. So your indifference curve shows a combination of two goods that provide the same level of satisfaction to a consumer. So in this case, we've got apples and bananas. You're pretty much ambiguous as to which one you're consuming. As long as you're receiving one, you're receiving the same amount of utility. They are always downward sloping. So all indifference curves will have this shape, okay? So in the same way that the PPC graph was concave, these are convex. So as you can see, they are still showing a combination of these two goods. In the same way that we did with the PPC graph, where we had an economy that only produced two products. So you'll see a lot of reoccurring themes, a lot of reoccurring curve shapes. So it's useful to draw the connection in your mind. So they're downward sloping because to maintain the same utility, if the consumption of one good decreases, the consumption of another must increase. In this case, if we reduce our consumption of apples from 14 to 10, then we expect to receive more bananas to compensate for what we've lost. In which case, point A, point B, and point C all give you the same level of satisfaction to the consumer. That's why we call them an indifference curve, because you are indifferent to which product you consume. You simply want to consume them. Okay, so they are convex to the origin. They reflect this diminishing rate of substitution between goods. So you'll see as we move towards the higher level of consumption of apples, we see a steep decline in the necessity or requirement for bananas, in the same way for bananas with apples. The difference between point A to point B is 4 apples, and yet the difference from point B to point C is only 1 apple. Okay, and yet you can see that here, the reason that we have this convection is because from point A to point B with regards to bananas, you'll see that we require 6 bananas to compensate for those 4 apples. Whereas from point B to point C, despite the fact that you are deriving the same level of satisfaction, we now are consuming 1 less apple, but we expect 15 additional bananas. Okay, so you can see that there are extremes on either end. In the same way that with the PPC graph, the only difference was because it was in the opposite curve direction, we had a point where we were actually touching the axes. You'll notice that these indifference curves never touch the axis. Okay, so they never intersect. No two indifference curves can also intersect. Yes, that's another good point. You will not just be drawing one indifference curve, you will be drawing many indifference curves. Now, the reason for this is each curve represents a level of satisfaction to the consumer. So the only thing that is increasing here is your overall satisfaction for the consumer. He is indifferent between the level of apples and bananas. The combination is less concerning than his level of satisfaction. Higher curves mean higher levels of utility. Indifference curves that are further from the origin, in other words, the further right you get, the higher your level of satisfaction. You can see that would be a natural assumption if we just extend this point over here and the same all the way to the left axis. You'll see that here we are deriving from 41 bananas and at least, shall we say, perhaps maybe 16 apples. You will obviously be deriving a higher level of satisfaction, one would assume. Okay, we do know that we have our law of diminishing marginal utility, but that is implied in this curve itself. So simply by increasing your indifference curve to the right, you are increasing your utility. Now, this collection of curves together is called an indifference map. It is a collection of representing a consumer's different preference structures. Yeah. Okay. So we come to the budget line. Now we all have restrictions. We have endless ones, and we unfortunately are very constrained by the resources we have to fulfill our wants. So we have to consider the budget line because it is not simply about being able to choose which product you want to derive your satisfaction from. It's about how are you possibly able to afford it. The budget line represents all possible combinations of these two goods that a consumer can purchase with a given income at fixed prices. Okay, so here again, you will always have your two products. You'll notice that we are setting you up to be able to combine all of the graphs that we have covered previously. We'll take a look at that in a little bit more detail later. So of all the graphs that we've derived, okay, before we cover the next one, I just want to remind you of the graphs we have covered. So here we started with our marginal utility, okay, the downward sloping graph indicating that each additional unit we derive less satisfaction from. We had the total utility graph, which indicated that to a point until marginal utility hit zero, we had an overall increase in our total satisfaction level until marginal utility hit zero, at which points we started hitting disutility. In other words, we started receiving negative impacts from the additional units we were consuming. Next, we had our law of diminishing marginal utility. Okay, not to be confused with your budget line, despite the fact that they look similar. Okay, you will notice that the law of diminishing marginal utility never touches the y-axis. Why is that? Because zero level consumption of apple will not derive you 30 utils of satisfaction. Okay, so we have to start this graph at point 1. At least one unit must have been consumed because marginal utility is each additional unit. So at one point we had 0 and then we have 1, and that's where we start our graph. Okay, so that is the key difference between this graph and the budget graph. Of course, in shape, apart from the fact that they are obviously representing very different economics principles. So what we have here is just a simple representation. We've taken out the total utility graph and we focus just on marginal utility, but here we've simply applied the values to the y and x axis so you can see a proper representation of why this curve is represented this way and at what point it turns negative. Okay, then it was very useful for us to understand the difference between averages and marginal. And we had the comparison between marginal and average using costs. You'll notice that as long as your marginal levels are increasing over time, your averages are being brought down. But when they start to hit a certain point, you start to have marginal cost. Sorry, when your marginal cost is greater than your average cost starts to increase. So that is a representation of what is happening here overall. So at a point, we hit the point when the average was now being negatively impacted by each additional unit that was being consumed. Okay, then we had the indifference curves. So the indifference curves is a representation of the utility of a consumer from consuming two separate products. Okay, so here, these curves are slightly different in that instead of reflecting, for example, price and quantity, as you would expect a demand curve to depict, we instead have our two products. Okay, so here indifference curve again is showing these two products, and the reason that it is curved is because you demand different levels of compensation. As you decrease the consumption of one product, you may demand slightly more of another. All of these curves together create an indifference map. And now we're back to our budget line. Now, I want you to be able to visualize simply the overall total marginal utility, and I want you to be able to visualize the indifference curves on this chart. Okay, so here where we're looking at the budget line, we are obviously trying to maximize our utility. So what this curve represents is, again, these two products, but it is looking at our total value that we have available in our income, and it is looking at the fixed prices of these two products, and it is calculating how much of each we can afford to buy. So this is the restriction on our indifference curves, because the budget is the thing that decides how much of each product we can afford to purchase. As you can see in the formula, price over the quantity of X plus price over the quantity of Y must equal our income. The reason we say that is because in this scenario, we are not saving anything. We're trying to spend the entirety of the budget. Okay, so here you'll see that there is a slope indicating a negative of the price ratio. So that means that here, if we were to buy 10 units of shoes, we would be able to purchase 0 clothes. As we are willing to decrease our consumption or purchase of shoes, we can then increase our purchase of clothes. So as one increases, the other must decrease. Okay, so because there is this compensation, we have this negative slope. At the x-intercept, you'll see that here we have the maximum of good x. If all of our income is spent on clothes, we can buy 5 units of clothing. At the y-intercepts, if all of our money is spent on shoes, we can buy 10 units of shoes. Now, if your income increases over time, you will notice that your budget line will shift, obviously. What is this indicating to you? That you are now able to afford more of each product. Your budget line rotates, however, when there are changes in price. In other words, you could end up, if there is an increase in the price of clothing, you could end up with a budget line that rotates inward and moves closer to the origin. What is this implied? If your budget was, for example, 25 Rand, let's say 50 Rand, each unit of clothing costs 10 Rand. That means at the original point, you could afford 5 units of clothing. However, if there's an increase in price, and instead of 10 Rand for each item of clothing, it now goes up to 15 or 17 Rand for each item of clothing. That means that my budget line is moving inwards, and I can only now afford to buy 3 units of clothing. Same thing would happen with shoes. If we found that there was an increase in shoes, we would have a movement inwards towards the origin in shoes. This is, of course, assuming that there is only one change in price. It is either applied to shoes or to clothes, but not to both of them at the same time. If, however, we are unlucky enough to have a point where the price of shoes and clothes goes up at the same time, we would have this impact, where our budget line would shift entirely towards the origin and would move to the left, decreasing our ability to buy both shoes and clothes. And here is where we put it all together. If you see the words consumer equilibrium anywhere in your assignment or in your exam, this is the graph that they're looking for on the right. There are variations, obviously. There may be incorporate specific values for commodity Y and commodity X. However, this will always be the shape of the graph. Also, please note for assignments, I have mentioned once or twice, it's very difficult to accomplish these complex graphs in tools like Excel or PowerPoint, in which case I would be completely fine if you were to draw these freehand using pen and paper and simply incorporate the pictures you take into your assignments. Now for your consumer equilibrium, This is the point which occurs where your indifference curve is tangent to your budget line. So remember everything that we have just discussed. Your indifference curve is your measurement of satisfaction for your consumer. The higher the indifference curve, the greater the amount of utility you receive, which means that in this graph, I3 derives the consumer more satisfaction than IC1. So the point of the consumer is to maximize their levels of satisfaction. They are, of course, constrained by the budget, which is the line that you see drawn from B to A or from A to B. That is telling you exactly what this consumer can afford. If, for example, they were to buy a commodity X and put all of their budget into commodity Y, they would be able to purchase B of Y commodity. If, however, they purchase nothing from commodity Y and they put all of their income into commodity X, they would be able to purchase level A. You'll see we use B and A here because if they are not specific values, it is the shape of the curves that are most important. So at your marginal rate of substitution, this is what your consumer is willing to substitute one good for another at. Okay, so if you are looking from B to N, you have to look at how much your consumer is willing to sacrifice. At this point, they would be willing to sacrifice from A to M. These levels of consumption can still derive the same level of utility. We are simply looking at the difference between the two. So your consumer equilibrium is this beautiful point here at E, where your indifference curve is lying tangent to your budget line. So this implies you are using the maximum amount of money and deriving the maximum indifference curve or utility that this consumer can afford. This is an ideal situation for the consumer. Maximum utility has now been achieved, given the consumer's budget restraints. The law of substitution says that the consumer substitutes goods until the marginal utility per dollar or per rand is spent is equal for all goods. So you're trying to reach a point where you are maximizing your utility. So as long as the point here where the curve hits is telling the consumer exactly how much of commodity Y and commodity X to purchase. Now, what we have here are a series of effects on price and income. Any of these could be applied to your exam. So it's necessary for us to spend a little bit of time looking at the different effects and the impact on these graphs. With your income effect, change in consumer consumption due to a change in purchasing power. So when real price changes. So in other words, if you have a shift in your income, that means that your purchasing power has been reduced. This means that your consumption overall can shift to the left, which would obviously impact your budget line. What this could often mean is that you're moving from one indifference curve to another. Remember, as your income decreases, so must your consumption, and as such, as a result of which, obviously your utility decreases as well. The substitution effect means that there will be a change in consumption due to change in relative prices. So if your income is not the thing that changes, it is often the case that you may simply change your consumption due to relative prices. So if the price of clothes goes up, that means that you can actually buy fewer items of clothing, in which case you may instead prefer to buy more shoes. Okay. So there is of course, on the understanding that you are deriving the same level of satisfaction from both shoes and clothes. If there is a compensation, so your product that you prefer becomes more expensive, you can still derive the same level of consumption, of utility, by simply buying more of another product. Then there is the price effect, which is the last one we have to consider. This is when the total effect of a price change. So it is both the income effect and the substitution effect, in which case you will see these derivatives. Both your indifference curves are shifting to the left. The price of product X has obviously gone up, it's increased. So it was this original point, and then it started to become less and less affordable. So as a consumer, we were first on this initial indifference curve, but if our income is to shift, that means that our budget line shifts to the left. We are now able to afford fewer of that relative good, and therefore so does our consumption decrease. On our indifference curve, we find ourselves falling lower and lower. You'll also notice that the indifference curves can be positioned differently along the tangent of the budget line. This indicates the shift, the consumption, the substitution effect. So instead of buying Y3 of good Y, you would instead go to X3. Sorry, you would instead, when you move down to your second level of indifference curve, you would instead consume a little more of good X and far less of good Y. Why? Because it is simply more expensive. Okay. On the other hand, if there's a massive increase in the price of good X, you'll see that your preference again shifts lower. You are now consuming comparatively less of good X than you are of good Y, because it is now relatively more or less price adjusted. Okay, so that's how our substitution effect works. We do adjust the combination of goods we consume based on the relative prices of each good. And with regards to income, when if our income changes, if our real purchasing power changes, then it moves our budget line across. Okay, so if there is an increase in your income, your budget line will shift to the right, because it means that you can now afford more of that specific product. It will generally be a parallel line to the original. Okay, so here is the example of this. So if you look at this blue line and this orange line, this increase implies an overall increase in income. If there is a price decrease, there will be a budget line rotates outward from the axis of the unchanged good. So if there's a price decrease, which has happened here from the blue line to the green line, we see that there is an outward shift. Yeah, because we are now able to afford more of good X. If we are looking at normal goods, consumption increases when income increases. If, however, you are provided with a case study for an inferior good, it means that consumption decreases when income increases. So, for example, here where we have an increase in income, If there is no increase in the amount of good that is now purchased when you receive a higher income, for example, if you receive a 20% increase in your salary, it doesn't necessarily mean that you will now purchase more bread or more samp and or beans or wheat or things that are particularly, not luxury goods. What typically happens is when your income increases, you will stop choosing more inferior goods and you'll instead choose rye bread and these artisan breads. Okay, so you'll aim for more luxury goods and buy fewer of the inferior goods, the better your income becomes. With normal goods, however, they ascribe to the normal demand curve. Their consumption increases as the price or your relative price decreases, which means that your income overall has increased. So the price of that relative good to your income. So as a percentage of your income, this good represents a relatively small proportion, then it's very likely that you can increase the amount that you consume if your income increases. So over here we have your overall PCC graph, not to be confused with your production possibilities curve, so your PPC graph. Your price consumption curve connects all your consumer equilibrium points. So it considers both your budget as well as your indifference curve, which is showing both your substitution and your income effect. So your PCC connects all your consumer price points as the price of one good changes while income and price of the other goods remain constant. Okay, so this first graph here is implying that this good is not increasing. Your price is not increasing. The quantity of goods that you are demanding is increasing as your income increases. So we start point one with the consumer equilibrium at a given price. Then there is a change in the price of one good. So a decrease in the price of X will then lead to an increase in the demand for X. Okay, so we also see a movement outwards. Okay, why? Because it means that we can afford more of good X. So you'll see a shift from point A to point B. The budget line now rotates, creating a new equilibrium point at point small b. Okay, so your tangent has moved outwards. Therefore, there is a new equilibrium point where your budget line now meets your new indifference curve. Now, if you connect all of these equilibrium points, you form your PPC, which is your price consumption curve. Your price is now being accounted for in your consumption preferences. Now, when we plot all these price quantity pairs on a separate graph, what do you get? But your demand curve. So your demand curve is a consideration of all of these aspects that we have considered. This is looking at your budget line, your substitution, your preferences for one product over another, your indifference curve, the objective of your consumer to maximize their consumption. And when we plot all of this information together and we draw our PPC, you'll see that it perfectly aligns with the price and quantity demanded. And this reflects our demand curve. It is downward sloping because it also is reflecting the law of diminishing marginal utility. Each additional unit you are consuming gives you less satisfaction. And in addition to that, the more expensive something is, the less of it you demand. Okay, so with 10 minutes left, I'm just going to give you a quick summary. I'm just going to pause this video.